The assignment for next time is going to be a radical assignment. In other words, it's an assignment dealing with radicals.
Radical.
And let me give a numerical example of a radical. A simple example, radical 25, or the square root of 25. And what does that mean? What is the square root of 25? I think everybody probably knows that already, don't you? 5. Okay? Now, before we go into any long explanation of radicals, it will be helpful to review what we call perfect squares. Everybody remember what a perfect square is? Let me make a list of some perfect squares. Like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared, 16, 5 squared, 25, 6 squared, 36, 7 squared, 49, 8 squared, 64, 9 squared, 81, 10 squared, 100. Is that far enough? I think we need about 2 or 3 more. How about 11 squared is 121, 12 squared, 144, and 13 squared is 169. Okay, those are the perfect squares that you need to have in your recent memory. You need to have these in the front part of your brain when you do a problem involving the square root, because every time you have a problem that says square root of 25, it's going to be like one of these numbers is going to come to mind. Okay? Now, if when we said the square root of 25, everybody said 5. But how do you know that it's 5? What would you have to do in order to check this? You'd have to say 5 squared is 25, right? In other words, the square root of 25 is 5 because 5 squared is 25. Now, what about the square root of 49? Square root of 49 would be 7. How do we know it's 7? Because if you take 7 squared, you get 49, see? If you take 7 squared, you get 49. What about the square root of 121? What would that be? 11. And how do you know it would be 11? Wrong color.
We have a calculator.
Because 11 squared is 121. And I heard somebody say, because you have a calculator. And I'm so glad you said that. Because I want you to learn to use that calculator, the one that's between your ears. And, yes?
How about if you divide 11 into 121, come up with 11?
That'll do it also. If you divide a number by some number and it comes up the same as what you divided by, that makes it the same. Okay?
That's the calculator.
Now, let's talk about the calculators. Everybody have their calculator with them today, because you're going to get a chance to use this. In addition to the one between your ears, let's take the handheld calculator and see if everybody knows how to do the square root of 25 with a calculator. Take your calculator and give it, what, 25 first? Most of you will probably be entering 25. And then you probably have this thing on your button, the square root of x. Does it say square root of x? Does it just say square root?
Just square root.
Some of it just says square root. Some of it will say square root of x. Okay? Then hit that button, and it gives you the answer immediately. What's it give you? 5. Okay? So the answer is 5. Okay? 5 is the answer.
On our calculators, how can we do the square root of x to the 4th?
We'll get to that. We'll have to do that something first. You can't do it right now with a calculator. Let me do another one. What about 49? Give your calculator a 49, and what does it give you? 7. Okay, you hit the square root button, and it gives you 7. All right? While we're at it, let's take a larger number. How about giving it a number like 961? And in other words, take the square root of 961. That's a nice number, isn't it?
31.
Comes out 31, huh? In other words, if you do the square root, do they all come out even? Every time I give you a number, is it always going to come out even like this did? That was a carefully selected number. Hey, I got another number for you. I want you to do 1,525,225. 1,525,225.
Square root is 1,235.
How much is the answer?
1,235.
1,235. That's kind of a nice number, isn't it? Now, do you have a squared button on the calculator also?
Yes.
Let's go back to 25. Take your 25 and hit the square root button, and you get what, 5? Now, do x squared. Do you have an x squared button on the calculator? Then hit the x squared button, and what do you get?
Don't want to look at that number.
It checks it.
25, right? That's the check. That's the check. Take 49. 49, put it in the calculator and hit the square root button, and you get what, 7? Now, hit x squared, and it goes back to 49. Now do square root button, and what does it give you? 7. Now do x squared, and what does it do?
Back to 49.
Back to 49. Do you see what square root does? Square root is the opposite of squaring. Square root is the opposite of squaring. Okay? And if you took 1, 2, 3, 5 and hit the x squared button, what do you get?
1,500,000.
You get this big number, don't you? Okay? And then hit the square root button, and what do? You go back to 1, 2, 3, 5. So you've just learned something about what is the square root. And you learned you took the calculator to learn what is a square root. It's the opposite of squaring. Now that's what I tried to tell you with this little definition up here. The square root of 25 is 5. And how do you check it? By going 5 squared is 25. But with the calculator, that really shows you what a square root is. It's the opposite operation of squaring. It undoes the x squared button. Okay?
Are you saying the opposite of squaring?
The opposite of squaring is square root. The opposite of squaring is the square root. Okay? Now, while you're at it, while you're at it, I want you to do one more thing. Let's try the square root of 0. What's the square root of 0? It is 0, isn't it? The square root of 0 is 0. Does that check? 0 squared would be 0, wouldn't it? Okay, so the square root of 0 is 0. One more. How about the square root of -1? Give your calculator a -1. Now, do you know how to do that? You might have to go 1 and then hit the plus or minus key to change it to -1. Hit the plus or minus key. You'll have to enter you probably have to enter 1 and then hit the plus or minus key. That changes it to -1. And then hit the square root button. And what does it say? Error. It says error. Now that's important because you have to know what your calculator is telling you here. What is the calculator telling you about taking the square root of a negative? It's undefined. In other words, it's not allowed in the real number system, you see. You're not allowed to take the square root of a negative number, okay? Think about this. What if we tried to do it by hand without a calculator? Remember we said any number you do the square root, you can check, like the square root of 25 was equal to what? 5. And how do you check that? Because 5 squared is 25. Okay? Now, I want to take the square root of -1, and I want to get some number. Now, what number would I have to square? What number would I have to square in order to get the -1 back? If you squared a positive, what would you get? A positive, and it wouldn't be negative. What if you squared a negative? You'd get a positive, wouldn't you? And what if you squared 0? You'd get 0. So what's left? There is nothing. If you can find a real number that we can put on this blank line here, and then consequently square it and have it come out to -1, you let me know. I want to talk to you. If you've got a number we can square and end up with a negative number. Yes?
What happens if you have a negative sign outside of the parentheses?
Now, if you had a negative sign outside the parentheses, that would be okay. But see, whatever number it is here, that's the number we have to square. The number you put on this line has to be what is squared. You can't put a negative outside of it. That's not fair. We have to take a number and square that number to end up with a -1. And there is no real number. Now, I'm not saying there is no solution to that, because later in intermediate algebra, we're going to get into imaginary numbers. That is a possibility. But for right now, we're not talking about I numbers. And on this level, there is no real solution. So
imagine the number.
imagine the number. Yeah.
Imagine that I got all the exam questions right.
Just plug in I.
Imagine that. All right. But we'll have to wait for intermediate algebra to have a square root of a negative number. All right, now that's just a thought, and I wanted you to see, while we're talking about square roots of numbers, that you can't do that if it's a square root of a negative number. Okay? Now, next thing I'd like to talk about is, what if you had a square root of something with an exponent in it? Let's say you have a square root of x squared. A square root of x squared. Anybody want to take a guess?
X and X?
X. Okay? Now, in order to check this, to make sure it's right, what you'd have to do would be say x and then square it, and then that would be x squared. Now, that was brilliant, wasn't it? X squared equals x squared. In other words, the check would be that we have to square something and end up with x squared. Okay? Maybe it'd be more interesting if I took the square root of x to the 4th. Any guesses what x to the 4th might be?
X squared.
X squared. That's a very good guess, isn't it? Now, how would I check that to make sure?
X
I have to take the x squared and square it. And what do you get? X to the 4th. See? So it works, doesn't it? Okay? Now, what if I gave you a problem like the square root of x to the 9th? Any suggestions as to what it might be? X to the 3rd, probably, right? And then in order to check that, what would you have to do? X to the 3rd, and we'd have to square it in order to get what?
X to the 9th.
X to the,
Oh, wait. Yeah.
uh-oh, x to the 6th. Now, if this comes out x to the 6th, what does that mean about the square root of x to the 9th? That means that this is not right. In other words, it isn't that you gave me the wrong answer, maybe I asked you the wrong question. Is that possible? In other words, I should not have asked you the square root of x to the 9th. That was almost a trap. Well, it wasn't almost a trap, it was a trap. It should have been x to the 6th. You see, the square root of x to the 6th is x to the 3rd. And then how do we know? Because if you take x to the 3rd and square it, you'll get x to the 6th. Okay? So, forgive me for that. Now, one more problem. What about the square root of x to the 10th? Any ideas what that might be? You see, if it was the 6th power, we ended up with 3. If it's the 10th power, we're going to end up with what? X to the 5th. And then the check of that would be to say x to the 5th squared would be how much? X to the 10th, right? X to the 10th. Okay? Does that make sense? In other words, what do you do with the exponents? What do you do with the exponents when you take a square root of something with an exponent? You have to take half of it, don't you? Take half of the exponent. Half of 10 would be 5. Half of 6 would be 3. So when you're taking a square root with exponents, you take half of the power. Okay? Now actually, the x to the 9th, you can't do the square root of x to the 9th yet. You can't do the square root of x to the 9th yet because it doesn't come out even. Now let me review one thought. If I asked you for the square of a number, Now I want you to think and be very careful about this. I want you to give me the square of 4. The square of 4. Now I chose my wording very carefully here. The square of 4, what is it? 16, right? Did everybody get 16? Notice the difference between the square of a number and the square root of a number. This is not just an abbreviation or a slang one for the other. They are completely opposite operations. If I ask for the square of 4, I'm looking for 4 squared, which is 16. Okay? All right, now, the square of 4 is 4 squared. Now, the other word that we sometimes use is this, square root of 4. Now, is the square root of 4 the same as the square of 4? It's exactly the opposite. The square root of 4 means this. It means the square root of 4, which would be 2. So anytime you say, and anytime you mean square root, be sure you say square root. Anytime you mean square, be sure you say square. Okay? All right, now, suppose you had a problem like that doesn't come out even. So I need to do 2 more problems, 2 or 3 more examples for you. What about the square root of 16x to the 8th? What would be the square root of 16x to the 8th? 4. All right, and so take the square root of 16 is 4, and then the square root of x to the 8th would be x to the 4th because you divide the exponent by 2. What would be the square root of 25x to the 12th power? First, take the square root of 25, which is, what? 5. And then we'll take the square root of x to the 12th, which is x to the 6th, okay? Because you take half of the exponent. Take the square root of the number, if it's a number, and then divide the power by 2, if there's a power involved. All right, suppose I had the square root of, let's say, 81, x to the 6th, y to the 30th.
So that's going to be 9.
9, okay.
X to the 3rd.
X to the 3rd.
Y to the 15th.
Y to the 15th, okay? Any questions on that? You take the square root of the numbers, and then you take that is the square root of the coefficient, and then if there are variables raised to powers, then you divide the power by 2. Okay? All right, good enough. Now, some of these answers don't come out even, do they? You may have noticed, like all the numbers I gave you so far, I always give you perfect square numbers, and then the answer comes out nicely. What if I gave you the square root of 50, for example? The square root of 50. Well, you don't know the answer to that, but you know something close to that, don't you? What's the square root of something close to that? Close to 50, that's
49.
49, all right? The square root of 49 would be 7. So if the number is a little bit more than 49, what do you expect the answer to be? A little bit more than 7. Try it with your calculator. Give your calculator 50 and hit the square root button. What do you get with a calculator? 7.07. 106 78 12. Ooh. All that for just the square root of 50. You'd be better off to leave it the square root of 50, wouldn't you? Now, another thing about this long number is, do you know that long number, as far as it's carried out, is still not exact. It's a rounded off answer.
But it's close enough if you take the calculator and square this number.
All right.
You use 50.
That's a good idea. Try it, taking your calculator and hit the squared button and see if it comes back to 50.
It does, exactly.
Some of you will say, yes, it does, and some of you will have a little bit of a round-off error when you try to get back to 50. So with that in mind, I want to show you how I want you to write the answer for the square root of 50. There's a way we can simplify the square root of 50 Even though 50 doesn't come out to a perfect square, there's a way we can simplify it, and that's to try to find some number, from this list here, from this list of perfect squares. Can you see any number that divides into 50 evenly?
5 squared.
5 squared, 25 in other words. So what I want to do is write this as the square root of, instead of 50, let's write 25 times 2. Okay? Now we have this property called the product property for multiplication. The product property for radicals. The product property for radicals that says that you can take the square root of 25 times the square root of 2. Okay? Now, does everybody in here know the square root of 25? Everybody in here knows the square root of 25, which would be what? 5. In other words, this part is just 5. And then nobody really knows what the square root of 2 is, except maybe as a decimal, and that would be the square root of 2. And that's the way we want to leave the answer. We want to get the number inside the radical to be as simple as possible, and then we want to be able to say some number times a radical that's been simplified. So, now calculate that. Would you take the square root of 2? Let's try this and see how it comes out. Take the square root of 2, and then take that answer times 5 equals. And what does that come out? 707, 106, exactly the same thing, right? It's the same thing, okay? So this is what we call the simplified radical form. Simplified radical form is when you try to get all the perfect square factors out of the radical and have a number times a smaller radical. Now, before we get into that in greater detail, I want to just give you some practice, and it will be helpful to really get these perfect square numbers in your mind. If these perfect square numbers are not in your mind, then you should have them on a piece of paper right in front of you. Preferably have them in your mind, but if you can't have them in your mind, have them in front of you so you can look at them. Now, here's a little game I want to play with you. If I give you a number like 20, I want you to write that as a number times a number, except not just any number times any number. The first number has to be a perfect square. All right, what would be the perfect square? If I give you the number 20, what perfect square goes into 20? 4, all right? 4 times what other number?
5.
4 times 5, okay? 4 times 5. Any question on that little game? Let me give you another one. Suppose I gave you a number like 40. Okay, 40. What would be the perfect square number?
4 times 10.
4, okay. 4 is the perfect square number that goes into 40. And what other number would you have to have? 4 times what would give you 40? 10. Okay. Now, is there a way you can use your calculator to help you out with this? Once you find the number from this list, then you can take the 40 divided by that perfect square number in order to get the other number. So even people that are weak in arithmetic skill can use a calculator to help them with this particular problem. And by doing this, you'll grow in your arithmetic skill, and you'll get so the goal is accomplished, you're not weak in arithmetic skill anymore, just by practicing these types of numbers. Okay?
Is that the only answer?
Is it the only answer? Sometimes there might be more than one answer. What did you have in mind?
8.
8, all right? 8 times what?
5.
5. Now, what was the rule that I gave you?
8 is not a perfect
8 is
square.
not a perfect square, right? So it had the little game that I'm playing has to be, the first number has to be a perfect square. Okay? All right, let me take a bigger number. Something like let's say 63. 63. What times what?
9 times 7.
What would be the perfect square number?
9.
Now you start at the beginning and say, well, let's see, 4 doesn't go, so it must be 9, right? So the first number would be 9, and then the second number would have to be, and with help from a calculator, if you needed it, what would you do to get the other number? Take take 63 and divide by 9, and that would give you what? 7. Okay? All right, how about 125? 125. What times what? What perfect square goes into 125? You might need to look at the list. Hopefully you have your own. 25, did I hear?
Yes.
25 times 5. Okay? All right, let's think of another number. How about 72? 72.
36.
Oh, I heard somebody say 36. Did I hear somebody else say 9? I hear somebody say 9 times 8. 9 times 8. And I think I heard somebody else say 36, didn't I?
Yes.
36 times what?
2.
2. In other words, here is one of these problems where there might be more than one way to do this. More than one way to have a perfect square times another number. But I'll tell you what, for the problems that we're going to do in the future, the best combination is going to be to get the largest possible perfect square. All right, now let's take this list of problems that we've come up with here and see if we can use this to find the square root of 20. To find the square root of 20 in simplified radical form, what I want to do is break it down into a square root times a square root. Now, what two numbers could you think of? So the square root of what? 4 times 5, okay? And then the square root of 4 would be 2. So that's 2, and then we'll have square root of 5, right? Take the square root of 40, for example. The square root of 40. How would you find the square root of 40? We've got to break it down into two separate square roots. So what's the first number? What perfect square goes into 40? The square root of 4. Okay? And then what's the second number going to be? 10. Okay? Now, can everybody in here do the square root of 4? The square root of 4 would be 2. Okay? Can anybody in here do the square root of 10? You can't do it, can you? You can't do the square root of 10. There is no number, no perfect square number that you can take time. There's no number you can take times itself to get 10, is there? So in other words, the answer would be 2 and then the square root of 10. Okay? How about 63? What if I wanted to do the square root of 63? The square root of 63. Now what I need is to make two separate square roots. What number goes in the first square root? What's the perfect square number? 9 times what? 7. Now, can everybody in here do the square root of 9? Everybody in here can do the square root of 9, which is 3. Can anybody in here do the square root of 7? No. The square root of 7 would be just the square root of 7. So the answer is 3 times the square root of 7. Okay? Any question on that? Let's do
The square root of 72.
the square root of 72. Okay, let's take a look at the square root of 72. The square root of 72. Now, that's going to have two different answers, isn't it? Depending upon which way you decide to break it down. What's the perfect square number that I said would be the best number to use?
The largest.
The largest one, which would be what? 36 times the square root of 2. Now, can everybody in here do the square root of 36? What would that be? 6. And then what else would there be? The square root of 2. Okay, that's the answer that I would want you to get. But somebody doing that problem another way is going to do it like this. They're going to say the square root of 72 is equal to, let's do it the other way. What if you said 9? What if you said 9 times 8? Now, what's the square root of 9? 3. 3, okay? So this part would be 3, and then the square root of 8. The square root of 8.
Comes out too large.
Now, we can simplify the square root of 8 some more because you see there's a perfect square in 8. 4 times 2. Okay, you could write that as the square root of 4 times the square root of 2. Now, what's the square root of 4?
2.
2. And what's 3 times 2?
6.
So what do you end up with for an answer here? 3 times 2 is 6 times the square root of 2. 6 times the square root of 2. Okay? Now, I think that's far enough to go for right now. I think what we need to do is stop and do a little bit of practice on this. So I'm going to stop right now and give you a chance to do some problems on this. And we'll come back and finish up an explanation in a minute. Okay? Now on page 315, I have something that I call the radical two-step. The radical two-step. And the first step is to sort, and the second step is to square root. First step is to sort, and the second step is to square root. So I'd like to take a problem like number 55. And I want to choose number 55 because there's a pedagogical error in number 55. That is, there's an error in pedagogy. Do you know what pedagogy means?
No, but I think we're going to find out.
Pedagogy means teaching technique. Teaching technique. So in this problem number 55, it says the square root of 72, x to the 10th, y to the 9th. Now, what I want to do is write this as two separate square roots. As a square root times a square root. And what I want to do is, step 1, I'm going to sort out the perfect squares to put all the perfect squares up front and everything that's left over in the back. You know, like your good stuff goes in the living room and extra stuff you put in the storage out in the garage. Well, this is going to be like your living room, this is going to be like your garage. Or maybe, you know, if you're flying on an airplane, some people fly first class, and other people fly coach. The left important people fly first class. They make everybody fly as coach feel like they're, you know, second class. You know, store them in the back of the plane or something. That's what we're doing here. We're putting all the good stuff up front, and everything that's left over we're going to put back in the storage area. So now, what perfect square comes to mind when you think of 72? 72. What perfect square? 36 goes up front. And what would be the leftover part? 2. So we're going to put 2 in storage. Okay? And now, x to the 10th. Is that a perfect square? Now, what was the deal? When we're dealing with x to a power, you have to be able to divide it by 2. And so what I'm asking is, can that be divided by 2?
Yeah.
Yes, it can. It divides evenly by 2. So let's go ahead and take x to the 10th. That is a perfect square. Put the whole thing up front. X to the 10th. Now what about y to the 9th? Now we're up to, remember we talked about x to the 9th a minute ago? But what I'm talking about now is y to the 9th. And you can't really do y to the 9th. So let's back off from y to the 9th down to a number that you can successfully divide by 2, which would be what? Y to the 8th. And put the y to the 8th up front in first class. Y to the 8th is a perfect square because you can divide the exponent by 2. Now what's left over? There's a y left over, isn't there? There's a y. So in other words, what I want to do is have the y left over in the second radical. Now I said there was a pedagogical error in this problem, and here's the pedagogy error. I gave you the 2y as a hint, and by me giving you the 2y in that problem, I made an error because I made you think that somehow you're going to start off with that 2y. You don't start off with the 2y. The 2y is left over. So if you're using my one-step third edition of this, that's, remember, you have to have this part before you can ever get the 2y. You have to have this part first before you can get the 2y. Now, everybody in here can do the yellow part, can't you? Go ahead and do the square root of 36, x to the 10th, y to the 8th. What would you have? The square root of 36 is 6.
Y to the 4th.
X to the 5th, y to the 4th, and then what?
X1.
You know what? There's nobody in here that can do anything with this, is there? So what do?
2y.
Just leave it, the square root of 2y. So when you do the square root, you take away the square root sign. And what's left over would be the square root of 2y. Okay, any questions on that?
Yeah.
All right.
What's the data?
The 8,
P minus the y.
I took y to the 9th as my starting point, and I back off from 9, because 9 is not divisible by 2. Back off to the first number smaller than 9 that is divisible by 2.
So you subtract 1.
Just subtract 1. Make it 8. And then you get y to the 8th, and then there'll be a y left over to make it a total of y to the 9th. Okay, any question?
Yes, you're doing that to get the square roots of exponents.
That's right. That's right. See, if it had been the square root of x to the 8th, you can go ahead and do the square root of x to the 8th, just divide by 2, x to the 4th. Now, the one I didn't get back to talk about was the square root of x to the 9th. And what do you do if it's x to the 9th? You can't divide that exponent by 2 evenly. So we'll break it up. Make it the square root times the square root. X to the 8th times x. Now, the square root of x to the 8th is what? X to the 4th, and then times the square root of x. Like that. Okay?
Now, are you talking with x to the 10th? You moved over because there's no perfect...
X to the 10th, right, x to the 10th is 10 is divisible by 2. So I just put the whole thing down. I don't have to break it up. I don't have to, because you can do the square root of x to the 10th, you don't have to break it down into anything. You can just go ahead and put x to the 10th up front. Okay? Now try a few problems like that on page 315. Page 315 is a very important page. Get lots of practice on that page. We'll continue this explanation next time. We're continuing today with radicals, and we're working out of the basic algebra one step at a time, third edition, somewhere around page 313 and 314. And last time we did some problems involving square roots. I want to continue that thought today. Let's start with a problem number 46 on page 314. And the problem says to take the square root of 98. Now, the square root of 98. With a calculator, you could take the square root of 98, couldn't you? You could just take 98, put 98 in the calculator, hit the square root button, and you'll get an answer that's almost 10. Won't you? 9 point something, would you guess? But that's not the exact value. There's something in math, we like to have the exact value. So let's go back and see if we can simplify this by finding a perfect square that divides into 98. Can you think of a perfect square that divides into 98? 49? Now, if you happen to think of 49, you're in business. Let's go ahead and put 49, and then 49 times what other number would give you 98? 49 times 2. So that would be the square root of 2. Okay? Now, I also want to mention, if you couldn't think of 49, then you can take 98. It's possible to take 98 and just break it down any way you can think of to break down 98. Like, what number goes into 98 that you can see obviously? What, 2? 2 goes into 98. You could say 2 goes into 98 and divide 98 by 2, and you'd get 49. That's the other number, 49. So in other words, it would be 49, and put the 49 first because that's a perfect square. Put the perfect square number first, and then put the other number second. All right, now, having broken it down into a perfect square times 2, and then the square root of 49 would be 7, and there's nobody in here that can give the value of the square root of 2 exactly, so we just leave it the square root of 2. So if you can do the square root of a perfect square, then do it. And if you can't, then you just leave it in the square root sign. Okay, any questions on that? Okay. Now, on the next page, page 315, let's take a look at number 51. Number 51 is partially worked for you. It says the square root of 12x to the 4th, y to the 6th. And in these exercises, I want to remind you of what I call the radical two-step. The radical two-step is where you take your first step to sort the radical and get all the perfect squares up front. And the second step, you put the leftover factors. Now, what perfect square divides into 12? Take 12. What perfect square divides into 12? 4. So we'll put 4 up front. Now, what other factor would be left over?
3.
And if you didn't know that, how could you use a calculator to help you with this? You can take the 12 in the calculator and divide by 4, and that would give you the other factor that's left over. That would be the 3. So you can use a calculator to help you with this. I want you to know that. Now, how about x to the 4th? What's the deal with powers? We talked about that last time. If you have a square root of x or y to a power, you want to be able to divide the power by 2. Okay? So you divide the power by 2. If you divide the power by 2, you'll get x squared. But we're not doing the square roots in the first step. Remember the radical two-step. The first step is to sort, and then the second step is to do the square roots. So all I'm doing here is sorting it out. Don't get carried away with yourself and do the square root of x to the 4th. Let's just put down the x to the 4th. Okay, so that would be x to the 4th because it's a perfect square. And y to the 6th? 6 is divisible by 2. It's an even number. So it's a perfect square. So we just put it down in as it is, y to the 6th. And we have no x's and y's left over for the second radical. All right? Now, everybody in here can take the square root of this first part, can't you? What would that be? 2x to the second, y to the third, and then the leftover radical just stays like it is, the square root of 3. So we've made what is in the radical as simple as possible. That's what we've done. Okay, any questions on that? All right. I think I'd like to do one more on this page. Well, looks like a good one. Does anybody have a question on 315? Anybody want to pick it out? I think I want to do one more. How about number 68? Okay. Number 68. Number 68, it says the square root of 80, x to the 100th, y to the 49th. I guess if you can do the hardest one, the last one is supposed to be the hardest one on the page, isn't it? So I guess if we can do this one, we can do them all. Right? Okay, let's make 2 separate square roots. Let's make a square root for the perfect squares and a square root for the leftover factors. Now, what perfect square divides into 80? And there are 2 answers you might give. Somebody might say 4, because 4 goes into 80, doesn't it? And somebody might say 16, because 16 goes into 80. Is one of those better than the other? If you get a choice between 4 and 16, take the largest possible one, which would be 16. So now what I'd like to do, instead of taking 16, which I told you is the best one to take, I'd like to take the other one and see what you would do if you picked the wrong one. What if you pick 4? Somebody might pick 4. If you pick 4, then how do we get the other number? Take 80 and divide by 4, which would give you 20. So you would have to put a 20 in the second radical. But now wait a minute. Is there a perfect square that's a factor of 20?
Yeah,
4. In other words, I shouldn't write that as 20, I should write it as 4 times 5. And now what about this other 4? This 4 needs to be brought over to the first radical because it's a perfect square. So we want to get all the perfect square factors in the first radical. So let's do that. Let's put the other 4 over here, which would be 4 times 4. And guess what's 4 times 4? 16, right? Right? So in other words, you end up with your 16 that I wanted. Even if you started off with 4, you still end up with 16 times 5. Okay? Now how about the x to the 100th? It has to be divisible by 2. The power has to be divisible by 2. So let's break that. Let's just put the whole thing up front. X to the 100th. It is a perfect square. Now, 49 is a perfect square, but don't let this fool you. 49 is a perfect square, but y to the 49th is not a perfect square because the power is not even. It's not divisible by 2. So back off from 49 and get what? Y to the 48, and then what's left over? There'll be a y left over, right? A y. Okay, now, everybody in here can do the square root of the first part, can't they? Everybody in here can do the square root of the first part. And that would be what? 4 x to the 50th. All right, good. Remember, divide the power by 2. Don't take the square root of the power. That's a trap that some people will get in a hurry here and say x to the 10th. That's not right. You're not trying to take the square root of 100. You're trying to take the square root of x to the 100th, which would be x to the 50th and y to the what? 24th. And then the square root of 5y.
I don't understand why it was 50.
Why it was 50?
Yeah.
Because when you take the square root of x to a power, you have to take half of the exponent.
Oh, okay.
Remember when you had the square root of x to the 6, what did you get?
3.
X to the 3. Why did you get x to the 3? Because you divide by 2, don't you? You divide the exponent by 2. Everybody can get that on this problem, I think. But when you get to a number like 100, there's a tendency to want to do something else. Almost entrapment. Okay? Yeah.
Do you always subtract 1 from it?
I always subtract 1 from it in order to make it an even power. You see, just subtract 1 to make it an even power.
So you just subtract 1 and bring 1 over there.
That's right. So there'll always be 1 of them left over. If it's an odd power, you're going to take 1 of the y's off and put it in the second radical in the leftover category. Okay? All right. Okay, now, continuing on to page 316, we've been talking about square roots, right? And I'd like to give you a little bit of insight about cube roots now, because I think cube roots will add to your depth of understanding. I want to start with something like the cube root of 27. The cube root, the little 3